Hello all, welcome to the Dev Team Law session on serverless. My name is Sanjay Kumar Bireli. If I might shortly introduce myself, I am a senior cloud consultant by Dev Team Cloud. I have a little more than 2 years of experience in IT. I have worked in banking projects and medical and construction industries. My main focus is developing microservices architecture using Spring Boot microservices. I have experience in working with CloudFormation to provision stacks, and I have also worked with Lambda functions for database CRUD operations. I currently live in Jena, which is close to Erfurt. I like playing games like cricket, table tennis, football, and FIFA. Let's start why we are here today. Serverless. What is serverless and why is serverless relevant? I have prepared the following agenda to discuss about serverless. We will talk about the evolution of serverless, define what serverless is. We will have a look at the serverless use cases. What are the AWS serverless services? AWS serverless architecture with an example, discuss about serverless pros and cons, and why is serverless relevant, and I'll also answer the questions. So let's jump right in. In the past, physical servers were used to deploy the software. This involves buying the physical hardware, installing the operating system, and also installing the necessary drivers, and making sure there is enough memory and processor available to deploy the software. This is basically known as bare metal deployment. The next type of deployment to later emerge is virtual machines. So with the development of hypervisors like Oracle, VMware, instead of deploying the software on a bare metal, developers were able to target a simulated server called virtual machines. Virtual machines gave a lot of flexibility with migrations and also upgrades, but it made the deployments more repeatable and flexible. We could also host more than one virtual machine on a given physical server. However, virtual machines had their own limitations and overheads. The follow-up to virtual machines was containers. With the development of container technologies like Docker, LXC, container deployment came into picture. Docker, the most famous container platform, runs applications on a same system by sharing same OS kernel. In each of these paradigms, there is a concept of where exactly the software is executing, whether it is on a physical server or it's on a VM. Serverless, on the other hand, promises to give us a new level of abstraction, just the code itself. We just deploy code and do not worry about where exactly the code is running. Let's see more details on serverless. Serverless is a new paradigm in cloud computing. It is a cloud-based service where a cloud provider dynamically allocates resources, storage, and memory needed to execute the code. The motto of serverless is to run code and not servers. Even though the name suggests serverless, that doesn't mean there are no servers involved at all. Servers are still involved, but service provider takes care of all the infrastructure, which enables us to focus mainly on business logic. And we also get faster time to market as serverless approaches allow developers to create new applications in hours and days instead of weeks and months. And generally, the code in serverless is executed in a form of functions, and the code in serverless Lambda can be written using Java, C#, Python, Node.js, Go, Ruby. So enough with the introduction to serverless. Let's see what are the real-time use cases of serverless. Serverless has a wide variety of use cases. It is used in edge computing, multimedia processing, IoT and fog computing, chatbots and mobile backends, and also used in high-performance computing. This is a graph that determines the serverless search trend in Google over the last 10 years, and serverless has seen a rapid growth in the market from 2015. Interestingly, Amazon launched its first serverless service Lambda in 2015. Most of the enterprises these days tend to move from a traditional architecture to serverless architecture using AWS. So let us see what are the serverless services that are offered by AWS. AWS serverless services are categorized into three categories. One is compute, which refers to memory, networking, storage, and other resources needed for any application to run. And data stores. It defines the way the data is stored. There are object stores, relational databases, and NoSQL databases, and also DWTs. And coming to integration, it is a service which enables communication between decoupled components within the microservices or serverless applications. Now let us have a look at them in more details. First, let us talk about AWS Lambda. Lambda is used to run code without provisioning any or managing servers. You only pay for your compute and there is no charge when the code is not running. You just upload your code to Lambda and Lambda takes care of everything like running the function and also scaling the function with high availability. The next type of compute is AWS Fargate. Fargate is a serverless compute engine for containers. Fargate scales and manages the infrastructure to run your containers. A task, generally Fargate has tasks. A task is a group of one or more Docker containers which are deployed with a specific settings. Coming to S3, S3 stands for Simple Storage Service. It is an object store service that offers scalability, availability, and performance. A wide variety of data can be stored in S3, such as you can host static websites in S3, you can have log files, backups, and archive files in S3. The next service is DynamoDB. DynamoDB is a fully managed, durable, and fast and flexible NoSQL database service. For applications that require constant and millisecond latency at any scale, DynamoDB is a preferred choice. Aurora Serverless. Aurora Serverless is an on-demand auto-scaling configuration for Amazon Aurora. Amazon Aurora is compatible with MySQL and PostgreSQL editions. It is simple, cost-effective for infrequent and unpredictable workloads. And in integration, Amazon SQS, SNS, and step functions are generally used to communicate between the decoupled components. In order to create and manage REST APIs or WebSocket APIs, we do have API gateway for that. API gateway generally acts as a front door for applications to access data and business logic from the application backends. And Amazon Kinesis is a platform that is used to stream data on AWS. Amazon Kinesis can process and analyze data at any speeds and respond instantly. The common use cases for Kinesis data streams is to analyze and load data streams like website click streams and also application logs. So these are some of the AWS serverless services. Now let us have a look how these services work in action with an example. This is a serverless architecture of an online shopping website where users can buy a wide variety of products and can also have a look at the purchase history. In this architecture, API gateway, Lambda, and Aurora Serverless are used. The Lambda functions in this example is written using Python 3.8. So whenever the client opens a shopping website from the browser, the API gateway gets invoked. The API gateway is used for authorizing the user. Only after a successful authorization, the user request is forwarded to Lambda. First, the Lambda then the Lambda function is invoked. The Lambda function is started in an instance and it gets all the product information available in the store. The data is retrieved from the product database, which is run using an Amazon Aurora Serverless, and this contains the information about product inventory. From the product list, the client could purchase any product, and as soon as the product is purchased, the purchase function is invoked, and the purchase it starts executing. With the purchase function, the price, the bills, and all the relevant information is stored in the purchase database. As soon as the search function and the purchase function is executed and it is finished, the function instances gets terminated and functions stay idle until the next invocations. And we are not billed when the functions are idle. Now, as we have seen a real-time example, let's look at the advantages and disadvantages of serverless. First, we'll discuss about the drawbacks of serverless. Cold startup for event-driven applications. Cold startup is generally one of the biggest problems with event-driven serverless functions. If a function is idle for a long time, when you trigger this function, the cold startup issue is seen. However, there is a potential solution that can be used, but it comes with a cost. We could ping our function from time to time to make sure it is not completely idle, and then the cold startup problem is not seen anymore. And the next problem is the API gateway only has a maximum integration timeout of 30 seconds. If the application has a long runtime and it also needs to generate a response to the client, then it is better to use EC2, ECS, or EKS instead of API gateway and Lambda, as API gateway and Lambda are generally designed for short runtimes. For high traffic applications, imagine the application has very high traffic and it has to handle many users. Then instead of using Lambda, AWS EC2 instances are more feasible and more cost efficient compared to Lambda. Debugging and monitoring. In general, it is more challenging to debug a serverless code. Developers also find it challenging to exactly dig deeper to get the detailed information on the issues and also the code smells. These are some of the disadvantages of serverless. But on the blind side, there are many advantages of AWS serverless. Lambda function, the timeout of the Lambda function has been increased to 15 minutes. Previously, the maximum execution time for Lambda function was only 5 minutes. So now it is easier to perform big data analysis, bulk data transformation tasks using longer running functions. And Lambda functions can concurrently scale at 500 instances each minute. Concurrency is nothing but a number of requests a certain function serves during a given time. Now, Lambda also offers 4 million free tier gigabytes per second. This also depends on the compute used for the Lambda functions. If the compute of the Lambda functions is increased, then the free tier gets reduced accordingly. And Lambda also has provided triggering with API gateway requests, which includes 1 million free requests per month. After the free 1 million requests, the billing gets started. And the billing is very cheaper. For the next 1 million requests, it only costs 20 cents. So, which is very cheaper compared to any EC2 instances that we used. With the pros and cons discussed, let's move on to our next topic, which makes why is serverless actually relevant. There is no concern for server management. Developers do not really need to worry about the underlying server, as the cloud provider takes care of the software infrastructure, setup, capacity planning. So this reduces the operational costs and also the development costs. Scaling is one of the major benefits of Lambda. It scales dynamically in response to the incoming traffic. If the traffic increases, then the number of concurrently running functions can also be increased by a predetermined amount. And costs, we only pay for what we use. The cost is also calculated during the function execution time. As the responsibilities of managing servers database is taken care by the service provider, now we could focus mostly on server-side code, which is mainly focused to improve the development. With reduced costs and increased efficiency, an event-driven serverless architecture could be a right move. But it could also be a poor choice of your company, depending on what sort of application you're building. Be sure to dive into serverless, knowing what components your application will have and how large is the application. If serverless seems a great fit, then there is no reason why you should not try it. And with this, I would say that serverless is relevant only if your application fits in the criteria. And if you have any questions, please feel free to ask me. I will be more than happy to answer them. And if you don't have any, then finally, I would like to thank you so much for your time. And if you're interested more in serverless, there are a lot of sessions on advanced concepts of serverless, which you may like and can have a look. I wish you all a nice day, and I thank you once again.